So we're looking at a different method for finding the remainder, and that's what we're going to have a look at now. There's another way to calculate what the remainder is without having to use long division. Okay? So there's a small proof to do first. I need you to watch the proof carefully. So I'll start it now.
Is this recorded right now?
It's recording right now, yeah. Right. Listen. I don't want to be delayed going home today, okay? So I need to do what I need to do, and that will take as long as it needs to take. And the more you talk, the longer it'll take. Get the idea? Yes?
As long as it's white, we're
Right. So what we'll have a look at now is the remainder theorem. Now, some people would have done this in high school, but I'll go through the proof and then, more importantly, the result. So last time we saw how to divide something like, let's say we have fx equals ax cubed plus bx squared plus cx plus d. And we want to divide fx by something like x minus k. So we know how to do that. That's with long division. So what we'd like to know is there a way to get to the result directly? That is there a way to get the remainder without doing long division? So what we'll do is, we'll take this and we'll divide it by this and we'll see what formula we get. Okay, so we won't use any numbers. We'll just use A, B, C, D, and K, and we'll see what formulas we get at the end. Okay, so let's have a look at this now. So we'll start here. X minus K divided into AX cubed plus BX squared plus CX plus D. Okay, so what do I get first when I divide? What should be my first term? Should be ax squared, yeah. So here we'll get ax squared, and this will be ax cubed. What's next? Minus akx squared. Okay, so that's okay so far. Then when I minus, these cancel, and I'm left with b plus ak bracket x squared. Yes. Plus cx plus d. Now it's getting a little trickier. So what's the next term up here? b plus ak x. Yeah. Okay, so let's do that. B plus AK x squared, and then the next one would be minus K times B plus AK x. And then now again we minus. So again I minus, these cancel, and now I'll be left with C plus K B plus AK x. Now we have to have double brackets here.
Do we have a D and a CX?
We'll get there as well. I have to carry the C and D down. Yeah. Oh, here, because it's minus. Yeah. And you're right, we have the D comes down as well.
What happened to the CX?
There's the C there. It was this with the X is taken out.
Oh, okay.
Yeah. Now there's only, well, the good news is there's only one left to do. So the last one will be plus bracket C plus K b plus ak, close bracket. Now, I know that looks quite messy, but at least it's the last one. So when you multiply it, you'll get c plus k, b plus ak, close bracket, x, minus k times bracket c plus k, b plus ak, close, close. When I minus for the last time, what do I get at the bottom? No, what will it be called at the bottom? It's the remainder, okay? So, these cancel, and what I have left at the bottom is the remainder. The remainder will be d plus k, c plus k, b plus ak, close, close. Now, in a way, we found the formula for the remainder. This is the formula to calculate the remainder, but we can simplify this. So let's see what happens when we simplify. So when I multiply, I get d plus k bracket c plus kb plus ak squared. And I can simplify some more. I get d plus kc plus k squared b plus ak cubed. And if I write it backwards, I get ak cubed plus bk squared plus ck plus d, which is what exactly? It's the original fx, except x is replaced by k. So we have f k here. So now we have this very short result that says if you want the remainder when you have fx divided by x minus k, you don't need to do long division. The remainder will just be f of k. So for example, if I have something divided by, let's say, x minus 2, for example, I don't need to do long division to get the remainder. I can just calculate f of 2. I just make x 2.
Couldn't you just put y equals x minus 2 equals 0 and then x equals 2?
Yeah, well, we'll get to that in a moment when we talk about factors and roots. So this here is actually the remainder theorem, that when you want to divide by x minus k, the remainder will just be f of that k. It's a tiny bit different if you have I mean like this. If you have like ax minus b. If you have something like this, not a lot, just a little different. Or should equal f of, does anyone know this one? B over a. Yeah. So no big deal if you have the a in the front, it just means you have to do a b over a inside of it.
Is it okay if you zoom out?
Yes, I'll zoom out a bit here. Okay. Too much or? That's okay. No, that's too blurry. Okay, we'll go in one level. Okay, write this down. This is the key thing. This is the remainder theorem.
I'm sorry. It's okay if you go a bit up.
How far is a bit?
A bit more.
A bit more? What?
There we go. Because, it was a lot.
Start writing, let's talk in more writing. Okay. How many people need to write this down? You wrote it down? Are you sure?
Yeah.
Did you write it down up here? Yeah.
We can just go on.
I didn't write down the final result. Yeah, no, did you get the 2 boxes at the end here?
No.
Okay, I'll need one more minute and then I need to push on. If you miss it, you'll just have to get it from
I think
YouTube.
it's better if we go on YouTube.
I'll go on in a minute. Go down a little bit. This is the end. If I go down more, I'll have to write more stuff. Okay, I'll push on. What? Okay, look, the most important thing to write down right now is what's in these two boxes. This is the result, okay? So if you have that, that's enough to move on.
Could you just give us a minute to write the boxes then? Last minute.
It's 4 o'clock. I'm tired. Give me a break, would you?
Actually, 4 to 20. I'm not making my case any better.
No,
Sorry.
no, you're not. No. The best thing you could do is be quiet. That would be the best thing. Okay, we'll push on now. So, you were saying earlier about, what do you need? This is B over A inside here. You were saying earlier about making it equal to 0 and to convert it. So we have a little bit of vocabulary with that. So for example, if I write down x minus 2, that is like, it's like a factor. Although it doesn't have to be a factor, it's like a factor. And if I write x equals 2 as the solution, what do we call that? Do you remember? That's called a root. Do you remember on the graph, we call these points here roots. This is called a root. So it's quite easy to go between the two. For example, if you want to change a factor into a root, what do? You just make it equal to 0. And then that means x equals 2. And likewise, if you want to go backwards, for example, if you have x equals, let's say, 2 over 3, then you just need to rewrite it until it's 0 again. So this would be, for example, 3x equals 2, which would be then 3x minus 2. So now it's back to a factor then, okay? So it's important that you know how to switch, because here, this is a root, and here, this is like a factor, okay? So this, which one? Ah, yeah, well, it's kind of like factorizing, where you make some part equal to 0 for solving, which we haven't really talked about, but it is related to factorizing, but we're converting vectors into roots or backwards then, okay? So let's just do some very simple examples. Let's say, for example, our first example, we want to make 2x minus 7, we want to convert that. So x, I think we all can see, will be 7 over 2. Yeah. Now, our next example, let's just say we have x equals minus 5 over 8. So what would the factor be? 8x plus 5 then. Alright, so there's two basic examples to get started. Now let's look at something a little bit more difficult. Can you check your notes for the very first long division example I did? So the very first long division example I did. You have it. So what was the cubic equation? 3x cubed plus 36x cubed
minus 59x squared.
Yeah.
Minus 6 by 6.
Minus 20?
2.
True. Okay. And I asked you to divide this by x minus 2 then. Great. So we should get the same answer for the remainder if we use the remainder theorem. So let's use that. Is there a mistake here? Yeah. So let's try it. Let's say use the remainder theorem. What should we use for x? X equals 2. So we'll put that in and let's see what we get. We get 36 times 8 minus 59 times 4 minus 25 times 2 minus 2. So if we hit that in on the calculator, let's see what we get. 36 times 8 minus 59 times 4 minus 50 minus 2. So this works out to be 0. Now what remainder did we get last time when we did it? We got 0. So you can see that the result is the same. We get the same answer. So the remainder term is a very important, very useful result that lets you find the remainder without dividing. So it's quite important, okay? We'll do some more examples, but this is our first example. So the question would have been, find the remainder. Okay, so if we can just write this one down as a basic example, and we'll do something a bit more difficult. I'll give you one to try, actually. That's what I'll do. Can I scroll down a little bit, just to like here? Yeah? Yes? Yeah. Okay, what I want is find the remainder when 8x cubed plus 14x squared plus 5x plus 2 is divided by 2x plus 1. Can you see it okay there? Yeah. So try this now. Try this one. What's wrong? Oh, what do you need? Let's check it. Yeah. Okay, so this one here, if we use the remainder theorem, then that means the remainder should be 8 times minus 2 cubed plus 14 times minus, sorry, I said minus 2, minus a half squared plus 5 times minus a half plus 2, and that will total 2. So that's the remainder then. That's okay. Yeah. Okay, let's look on an example that's more difficult than this. Okay, can I scroll down? Yeah?
Yeah.
Yes? Okay. So let's say something like this. X minus 1, so this is our next example. X minus 1 is a factor of, let's see, we'll go with 3x cubed minus 9x squared plus 14x plus p. Yep. And I don't tell you that, and that's what I want you to do. I want you to find p. So this one now, what do you think the key step here is, or the key idea? Yeah. Well, what do you know about the remainder if I tell you it's a factor? Yeah. So this is like me saying that the remainder is 0 when I divide by x minus 1, the remainder should be 0. So when I divide by x minus 1, the remainder is 0. Is that enough information to work out what the p should be? I think it is, yeah, because what you do is the remainder is going to be 3 times 1 cubed minus 9 times 1 squared plus 14 times 1 plus p, and that should equal 0. So it's more than enough to find p. So we get 3 minus 9 plus 14 plus p equals 0. So p is minus 8, is it? 14 minus 9 is 5 plus 3 is 8. Yeah? Is that okay, minus 8? Yeah?
You always subtract first, right? You always subtract first, then you go to
oh well, in this case, yeah. Okay, let me give you one that's like this to try, okay? Write this one down. This is, the example you're about to do is more like what you get in the exam. So usually in the exam they tell you a remainder. They would say, when something is divided by something, the remainder is some number. So you're given a remainder, but it's no big deal if you're not. If you're told it's a factor, then the remainder is 0. Okay. Scroll down, let's try one. Okay, try this one. Right. When 2x cubed minus 3x squared plus 8x plus p is divided by do I want to make it difficult? Yes. Divided by no, I won't make it difficult. Divided by x minus 1, the remainder is, let's say, 2. Find p. Okay, try this one. I have to check it now. Okay, let's have a look at this now. So what should I make x equal to? 1. So we have 2 times 1 cubed minus 3 times 1 squared plus 8 times 1 plus p. What should that equal? 2, yeah. So we have 2 minus 3 plus 8 plus p should equal 2. So p should equal minus 5. Yeah, so that's the p then. Okay, good. Yes.
Why you put 1?
That's the remainder theorem. So if I want to divide by this, I use x as 1. In my head, what I write is x minus 1 equals 0. So then x equals 1. So in my head, this is what we're doing. We're changing it from this to this. Yep. Okay, let me give you another example that's a little bit more difficult than this. So, next example. We'll say x minus 4 and 2x minus 1 are factors of px cubed minus 9x squared plus 4x plus q. And in this case, you want to find p and q. Okay. Try this one now. It's very, very similar idea. Well, it's the same idea. So you know that they're factors. So the remainder is 0 both times. finished or
I'm trying to figure it out.
don't know what's going on?
I have no idea what.
Maybe we'll do it now.
Yes.
Okay, you nearly have it there. Okay, great. Some people finished? Perfectly fine number. Yeah. And did you get P? Oh. Okay. Let's have a look at it now. So, firstly, if x minus 4 is a factor, then the remainder is 0. So when I use x is 4, I should get 0. So when I use x is 4, P 4 cubed minus 9 times 4 squared plus 4 times 4 plus q, that should be 0. What's that? 4 times 4 is 6. Is it 64? 64p minus 144 minus plus 16 plus q, that should equal 0. 6p plus q should equal 144 minus 16. So what's that now? 128? No. Yeah, 128. Yeah. Now this is not enough to find the p or the q. Is that right? Or did I make? Yeah. Oh yeah. What the heck? 64. Yeah. Is this enough to find p and q? No. No. But we can do the same thing with this one. What's the x here? Aha, yeah. So we next we have p a half cubed minus 9 a half squared plus 4 times a half plus q. That should equal 0. Right, so this will be 1 over 8p minus 9 over 4 plus 2 plus q equals 0. I think I'll multiply everything by 8 so I can get rid of this. P, so 8 times that is gone. I put in 8 here and I get 2 times 9, so that would be 18. 8 times 2, 16. 8 times q, 8q. So now I get p plus 8q. That's 16 minus 8, that's minus 2. Equals 2? Yes or no? I mean, did people leave them with fractions or did you simplify it? Question? Question? No? Okay. Well, let's see if I get the same answer as what you got.
0.
Yeah, well, let's check. So what you have now is 2 equations. Oh, come on. Please. Okay, so we have 2 equations. And we'll put them side by side. If you have a question, ask me. I'm not that scary, I promise. So are there questions here? It's okay. If you think I did something wrong, definitely tell me, okay? So we have our 2 equations, 64p plus q equals 128. And then our next equation is p plus 8q equals 2. So I think, I don't know, maybe the best thing to do is multiply this one by 8. So if I multiply this by 8, 64 times 8, is it?
Yeah.
512, yeah, plus 8q equals 128 times 8 equals 1024. And then here we have p plus 8q equals 2.
Elimination.
So elimination, there's a P here, sorry. So that would be 511, yeah, P equals 1020. Well, that's nice because I see the P is 2. So the P will be 2. And if I put that in here, the P is 2, that means the Q has to be 0 then. So I get the Q is 0 when it comes out here. So I think that's what some people were saying as well. P is 2 and Q is 0. Yeah? You made a mistake, but you can't see where, huh? I'll be with you later. Okay? No, I'll take care of it later. Don't worry. Later. Yeah. Don't worry about him. He'll be fine. Don't worry. I'll watch out for him, okay? Right. Let me give you another one that's like this. Now, before I give you the next example, let me just say again that this one I just did is very common for the exam, okay? And this is on most exams. I'd say, 80% of exams will have this type of question. Okay, so really when you think about it, all this question really is just two equations with P and Q. Most of the work was solving for P and Q. Only a little bit of the work was getting the two equations. Okay, so really it's just a degree 2 problem. Okay, I'm going to give you another one that's trickier. Let's see. Yeah. So again, I'll say it one more time. That last example was an important one for the exam. It comes up a lot. Right, try this one now. 15x squared minus, plus 13x minus 6 is a factor of px cubed plus qx squared minus 45x plus 18. Now, you need to think about this for a moment before you start it, because, well, what's the big difference here? Well, it's a quadratic here, and and P and Q, yeah. So we still need to make two equations to find P and Q. Yeah, some people might have an idea. Have a think about this. I'll do it in a minute, okay? I thought you might. Right, does anyone have any ideas on how to start it? Yeah, well, I think once you get the start done, then the rest is just like the last one. So the key is the start. Yeah. Yeah. Now, why factorize? What do you think? To find the x. Yeah, but why does that help? Seems to help. Yeah. Yeah, to get two values, but why do those two, what do you do with those two values? Put them in. Can you put them in? Why? For sure? Yeah, so if I tell you, think about this. Listen. If I say A is a factor of x, and A can be factorized, we'll say, into BC, then is it right to say each of these is a factor? What do we think? Maybe it is, maybe it isn't. So think about it like this. If A can be factorized as BC, we can say BC is a factor of x. I can divide B into x. Can I? Or can I only divide BC into x? What do you think? Yeah, well, maybe if we look at it with numbers, it might become a bit clearer. So, let's say a number like 150. Is 15 a factor? Yeah, and 15 can be split into 3 and 5. And are each of these factors as well? Yeah, because think about what you're doing. You're saying, I have x over A. I can change that into x over BC. And what's going to happen is, a bit like with, I'll stick with the numbers, 150 over 15. You can change the 15 into 3 times 5. And this is 115. Yeah, so that means part of it you can cancel. It can go in nicely. No, I think I'm making this too confusing. You all had the right idea, but I do wonder if any of you had the right reason for the right idea. The right idea was to factorize it to get the two factors. Yeah? Maybe I'll make it... No, I'll stop talking. I'll just make it worse. You are right. You should factorize this to make the two factors, and each of them can go in. Okay, so did you get the two factors here? What was the first one? 3x minus 1, and the other one is 5x plus 6. Wasn't it? Yeah. No, yeah, plus 6. So you should use x equals 1 over 3, and then x equals minus 6 over 5. And now it's just like the last problem that I did. You have two x's, you make two equations, and then you solve the two equations. So now it just becomes the same as the last example.
Shall we solve it? Or?
No, I don't think so, because it's just like the last one. Yeah. No, I do want to talk about this a bit more. I can't resist. Okay, so let's just look at this again. Right, so what type of equation is this? What's it called? And this one here? Cubic. How many factors here? 2. And how many here? 3. It's cubic. So I'm saying that this is a factor of this. So these two here, they must be the same as 2 of these ones. Because remember, we need 3 to multiply to make the cubic. If this is a factor, it means it can go into it. So that means 2 of them must be the same as these 2. So the last one is something different. So you can see that, well, then I definitely can divide by A, because A is in it. You know, I can cancel the A. Yeah, some people are nodding like, yeah, this makes sense. And some people are like, you should have finished 2 minutes ago. Anyways, it doesn't matter if you completely get it. The key thing here is to know that if this is a factor, then its factors are also a factor then. So you can kind of nest it like this. Right, so for homework then we'll just say B and C in each question. B and C.